Okay, so we're looking at lesson 3 and 4, examples from the textbook or practice questions from the textbook. So we're dealing with adding and subtracting rational expressions, and then solving, lesson 4 is solving rational equations. So question 6, adding and subtracting here, the biggest thing is you have to have a common denominator. Cannot add fractions no matter if they're rational expressions or just regular fractions unless you've got a common denominator. So I kind of, my hint is put brackets around the denominator if there aren't any, and remember that that's a whole factor. So if you take a look at C, you might think, oh, well, if I add 4 to the denominator here, I'd get x plus 2. And I could add 4 to the top, but that you can never add a number to the numerator and denominator and get an equivalent fraction. It's always with multiplying. So I always look at finding the lowest common denominator first. So I look at the first fraction and I just copy out whatever that denominator is. It's x plus 2, so I have to have that. Then I look at my next fraction. It has to have x minus 2 as a factor. Okay, done. That's my lowest common denominator. So I'm just going to copy out the actual question here, just so it's bigger. And as I said, I put brackets around that. So now to get my lowest common denominator for both, I need to multiply through. So I've got x plus 2, but I need x minus 2. So top and bottom by x minus 2. This one, I already have x minus 2, so top and bottom by x plus 2. Then I can write out as single factor or single rational expression with that common denominator, and now expand out. Okay, cannot divide. So sometimes people will I'll actually show you what they'll do. They'll show it like this, which is totally fine. But then they'll divide out the x minus 2's, divide out the x plus 2's, and get 3x minus x, and then get 2x, which is not the case. If you divide anything out, it has to be a factor. So x minus 2 would have to be in this term here and in this term in order to divide it out. And it's not, because this is a subtracting. That means that x minus 2 is not a factor of the whole numerator. Okay, so be careful. So really what we want to do is expand out. So that'll be 3x squared minus 6x minus x squared minus 2x over that denominator. I'm not going to expand the denominator because we want to simplify as much as we can. So we do have to expand out each numerator, then collect like terms. So 2x squared minus 8x. And again, over that denominator. Then it's just like lessons 1 and 2. You basically look at it, see if you can simplify that. So by factoring, we end up getting x minus 4, and nothing divides out. Okay, so actually, this would be a correct final answer, as is this. So either one. In terms of your restrictions, you want to look at your denominator before you divide anything out. So x cannot be negative 2 or positive 2. If you want to show that as plus or minus 2, you can. That's another way of showing it. Okay, so that is C. And now we'll look at E. And again, I'll copy that out. Well, actually, if you take a look at it, we can factor some of these denominators. So let's do that in our first step. So 2h, there's nothing to do. H squared minus 9, a difference of squares. So that's h plus 3 times h minus 3. Then plus h over. That factors to h plus 3 squared. It's a perfect square trinomial. Then minus 3 over h minus 3. Okay, so we've done our first step, which is factoring. I'm actually just going to move this down. And then Again, we want to find our lowest common denominator. So I'm just going to do my work here. So I look at my first denominator, I just copy it out. Then I look at my second, and that tells me I need to have h plus 3 squared. Well, I have one h plus 3 here, but that means I need to have another one. So really, that's the same as h plus 3 squared. Then looking at this, I need to have an h minus 3, which I already have. So this is your lowest common denominator. So that means that is our lowest common denominator. So we'll show it there. And then multiply each fraction to get that. So here, in order to get this as our denominator, we have to multiply by h plus 3. Okay, here, in order to get this, we have to multiply by h minus 3. Here, in order to get this, we have to multiply by h plus 3 squared. Always the same, numerator and denominator. Okay, so then you're going to want to expand out. When you're adding and subtracting, you have to expand. Multiplying and dividing, you don't. But here, so that's going to be 2h squared plus 6h, then plus h squared minus 3h. Then keep the negative with the 3. And this here, actually, I'm going to do this on the side. H plus 3 squared is h squared plus 6h plus 9. So when I multiply through by negative 3, I get negative 3h squared minus 18h minus 27. Now collect like terms, so that's going to be 3h squared minus 3h squared. That goes to 0. 6h minus 3h is 3h minus 18, so that's negative 15h, and minus 27. Okay, copy out the denominator. Then you want to see if you can factor. So that numerator, I'm just going to put this over here. So negative 3 is common, and you're left with 5h minus 9. So it looks like there's nothing else that divides out. So again, you could keep it like that. This for sure shows that you know that you can't simplify it any further. In terms of your non-permissible values, your restrictions, negative 3 and positive 3. Okay, so those are kind of the harder adding and subtracting. Next one, again, we'll do a couple of these. So let's look at A. So need to factor first. So here, looks like we can factor some numerators as well. So this is A. So I can factor out a 3 in that numerator, and then it's a difference of squares, so x plus 5 times x minus 5. Then plus, and then another difference of squares, 2x plus 1, 2x minus 1. And then here, that factors to, so 2x and x. Two numbers that multiply to negative 10 and add to 9 would be 10 and negative 1. So that would be plus 5 there, minus 1 there. And just check by expanding. Now, we could find our common denominator right now, but always check within a fraction to see if you can simplify, because you'll notice there, common factors there and there. Okay, so it's going to be much simpler than if you found a common denominator with unsimplified rational expressions. So now I'm just going to copy out what that leaves us with. So that's our first rational expression. That's our second one. Okay, so now our lowest common denominator is x minus 5 times x plus 5. So now I multiply top and bottom here by x plus 5, brackets there, and then here by x minus 5. Okay, and then so now it's one single rational expression, and our common denominator. It doesn't matter which order the factors are in, so that minus can be first or plus. Then we want to expand out the numerators, and that's going to be 2x squared minus 10 plus 1 is minus 9x minus 5. Okay, again, do not cross these back out because then you're back to square one kind of thing. So then here, copy this out again. Again, you don't expand the denominator, just the numerator, and collect like terms. Okay, that's a 10. Okay, and then factor. So I can see a 2 is common there. So I'm going to factor that on the side and then see if I can factor this again. Are there two numbers that multiply to 5, add to negative 3? No. So that really is the factored form. And that's it. Can't do anything more. So again, either this or this would be correct. Your non-permissible values, you do need to go back and look at the original before you divided anything out. So here, plus or minus 5, which you can see from the final, you wouldn't have missed that. But here, this factor here was divided out, and so we have to include that in our non-permissibles. So also 1/2. Okay, so these questions in this number 7, really you have to factor all numerators and denominators if you can, then find your common denominator as from the simplified form. Okay, so that's that type of question. Then these ones where this is really a division question of terms that are added or subtracted. So we're going to do C here. My hint on this is take a look and make sure all the numerators and denominators have been factored, and they have been. Then look at all denominators, okay, and find the lowest common denominator of all of them. So this fraction has a denominator of m. This has 2m plus 3, so that's got to be a factor. Here, m squared, so that means this needs to be squared, and this is 2m plus 3. So this is your lowest common denominator of all the fractions. So you can find equivalent fractions, or what's easier is if you take that whole numerator and whole denominator and multiply through by the lowest common denominator. So as long as you're multiplying top and bottom by the same expression, you haven't changed anything. So what's that going to be? If I multiply 3 over m by this expression, m goes into m squared m times. So I'm left with 3m times 2m plus 3 minus, and then the 2m plus 3's divide out, so it's minus 3m squared. And notice how all of the denominators are gone there. So this division is now this division, right? That stays. When I multiply through here, the m squareds divide out, and I'm left with 3 times 2m plus 3. You're just using the distributive property. And then the 2m plus 3's divide out here, and you're left with m squared. So now this is a much easier rational expression to deal with. And so can't divide out this 2m's plus 3 because they are not factors. There's a plus or a minus next to them. You need to expand everything. So that's going to be 6m squared plus 9m minus 3m squared. It's going to be 6m plus 9 plus m squared. And collect like terms, that's going to be 3m squared plus 9m. Descending order of degree. And then factor. because maybe you can simplify something here. So that's going to be 3m is common. You're left with m plus 3. And denominator, that's m plus 3 squared. So now this divides into one of those, leaves you with one of them. And, and then, so what we're left with is 3m over m plus 3. And your non-permissible values, couple of things. You look at all of the denominators, your lowest common, so you can't have 0 from that factor. Can't have negative 3 over 2. And then this whole thing can't be 0, but that's actually going to be here plus 3. So you want to look at this denominator here in factored form. So you can't have negative 3 as well. So basically all the denominators is what you want to look for. Okay, so those are called complex fractions, and that's how you simplify those. Then solving rational equations. So you kind of look at the same steps, find the lowest common denominator. So here, lowest common denominator. Actually, before we do that, let's factor all the numerators and denominators. So I'm just going to erase that for right now. So here I'm going to have 6 over c minus 3, because if you take a look here, I can factor that denominator here, okay? So now when I do that, actually, good thing, because that's, I'll put brackets there, those divide out. So really what I'm left with, 6 over c minus 3 equals 1 over c minus 3 minus 5. You can bring terms together. They're already like terms. Or I'm going to do the work that I normally do. Is I want to multiply through by the lowest common denominator, because that's what works for every type of rational equation. So c minus 3 is my lowest common denominator. And so now, rather than finding equivalent fractions all the way along, think about solving equations. Whatever you do to one side, you have to do to the other. So if you can multiply through one side to get rid of the denominator, then just do it to the other. And actually, I'll show that. Those divide out there. And then we get 6. And then when I distribute this, those divide out, and I get 1. And then minus 5 times c minus 3. So that would be minus 5c plus 15. And then collect like terms. And then bring the 16 over, so negative 10. And then divide by negative 5. That will give you 2. Non-permissible values, back up to your first factored form, would be 3 and negative 3. And you want to check. If this is a non-permissible value, then you have to eliminate it from your solution set. It's not, so that's your solution. Okay. Let's look at the next one, C. So again, factor if you can. And actually, you'll notice here, this is 2 minus d, so it's not in its normal order, descending order. I'm going to factor out a negative to start so that we get d minus 2 in brackets. Just in case we can simplify. So then our denominator will be d plus 4, d minus 1. Actually, I'm going to go back. Nothing divides out here. So actually, I'm going to leave it as it was so that I don't have to expand those brackets. Okay, so now my lowest common denominator has to have d plus 4, right, from that denominator. Then I look here, it has to have d plus 4 and d minus 1 is a factor. And then I look here, it has to have d minus 1. So this is your lowest common denominator. That's what I'm going to multiply both sides by. And when I do that, the d plus 4's divide out. So I'm left with d times d minus 1. Here, when I distribute this with the first, whole denominator divides out, so 2 minus d. Here, the d minus 1's divide out, so plus 1 times d plus 4, which you don't have to show the 1. And then you want to expand. And collect like terms, so that's going to be d squared minus d. That's going to be 6, so minus 6. You can factor that to d minus 3, d plus 2. So d equals negative 2 or positive 3. Non-permissible values are negative 4 and positive 1. So none of those overlap, so these are your solutions. Okay, so that's solving rational equations. Then I'll do one application. So this is kind of a distance, speed, and time question. So Ted is a long distance driver. It took him 30 minutes longer to drive 270 kilometers west, and then it took him to drive 300 south east. Anytime you have a distance, speed, and time, I do a T-chart. Well, just a chart. So distance, speed, and time. And there's two cases usually. So this is be the west portion, and then this is the east. Okay, so 275 is the distance on the west portion, 300 on the east portion. He averaged 10 kilometers per hour less while traveling west due to more severe snow. Average speed for each. So we know this information. It says he averaged 10 kilometers per hour less while traveling west. So I'm going to let my east be x, and this would be x minus 10. So I've got two columns filled in. Then I'll find the third. So distance equals speed times time. So time equals distance over speed. And that's what's going to be, I use that to fill in my third column. And then that third column there, it says it took him 30 minutes longer to drive the west portion. Okay, so because he was going a slower speed. So this is going to be more time, right? So that's going to help us come up with our equation. So this is a bigger number, okay, that 275 over x minus 10. If we subtract those times, then we'll get 30 minutes. Now, don't just put 30 here because this is in kilometers per hour. So 30 is half an hour, okay? So be careful of that. So do not put 30. Take a look at the units that you have. All right, so our lowest common denominator here has to have x minus 10, has to have x, right, and has to have 2. So really, we can put it the 2x out front. So I'm going to multiply by 2x, x minus 10, 2x, x minus 10, and distribute. So in there, the x minus 10s divide out, so I'm left with 2x times 275, minus the x divides out, so I'm left with 2 times x minus 10 times 300. 2's divide out, so 1x times x minus 10, and then expand that out. That's going to be 550. Oh, this is going to be minus 600 x plus 6,000 x squared minus 10x. It's quadratic. I want x squared to be positive. So that's going to be minus 50x. Bringing it over here is plus 50x, so plus 40x. Minus 6,000. So 60 times 100 gives me 6,000. And 100 minus 60 gives me 40. So I can factor this. Oh, sorry. Minus 60, x plus 100. So x equals 60 or negative 100. Negative doesn't make sense for this problem. So x is going to be 60. It says what was Ted's average speed for each part. So that's for east. So Ted's speed east of swift current is 60 kilometers per hour, and west is 60 minus 10 is 50 kilometers per hour. Okay, hope that helps.